presentations from our three speakers on the important topic of rethinking tech in STEM. And I think a large part of the motivation for this is the enormous capability of networks and graphics, and in particular, mobile devices and web browsers. So there'll be an hour for the speakers and questions and answers. Then if you want to leave, you'll be very welcome to without being disruptive. But the second hour allows us to meet our speakers and ask them questions in a smaller setting, because we'll have breakout rooms. And I think we're a fairly small group, there's 14 of us. So we'll sort of decide how we're going to organize ourselves, go into breakout rooms, and then at the end of that, have report backs in a plenary session. So let me introduce the speaker. An astronomer at Harvard Center of Astrophysics, and he's an innovation scientist there, which means his part of his job is making things better as a working environment. I think that's about right. Then we have Dennis Müller, who's a postdoc at Friedrich Alexander University Erlangen, and he's a member of a well-established organization called KWARC Quark, which is knowledge representation and processing. And one of the projects, I think, is the establishment of a digital mathematical library, and the idea that you can search for a theorem in the same way as you can search for a movie or a song or a restaurant. And then finally, we've got Martin Ruckert, who's a professor at the Hochschule Munich, which roughly translated means the Munich University of Applied Sciences. And he has done a very important piece of work. There's two sides to it. The one is a refactoring of LaTeX, but the other side of it is reflowable typeset text in the browser, or in a browser rather than the standard browser. He's recorded a very nice presentation about this, which is really well worth watching. And then I think he'll say a few words and maybe answer some questions. So I think that's enough to get us going. And without much further ado, I'll ask if Peter would be willing to give his presentation. Tell us about Tectonic.
Sounds good. All right, let me share my screen here. All right, can you see my title slide? Good. Great, yeah, I'm happy to be here and talk a little bit more about Tectonic. This will resemble the presentation that I gave at TUG 22 several months ago. Slimmed down a little bit, and I will show some a little bit of progress that's happened since then. And if you see me gazing up into the sky, that's because I've got this multi-monitor set up, and that's how things are. So to introduce myself a little bit more, I just wanted to give some context for what I've been doing. So I come to the tech world as a scientist, as someone who is involved in scholarly publishing, and as a software developer. So I'm an astronomer. I'm based at the Center for Astrophysics, Harvard-Smithsonian, which is Cambridge, Massachusetts, and also the American Astronomical Society, which is a scholarly society for astronomers in North America. As part of that latter affiliation, I'm the director of a software project called AAS Worldwide Telescope, which is a primarily web application for visualizing astronomy data, which has really fueled a lot of my thinking about sort of what you could do with the web browser these days. And I also work with the AAS Publishing Group. We have journals like the Astrophysics Journal, the Planetary Science Journal, which are really sort of the top tier journals in the astronomy world. I also work with a project called NASA ADS, which is based here at Harvard, which is the name is the Astrophysics Data System. It's a database of scholarly literature. It's at heart, and so it's kind of similar to Google Scholar in a certain sense, but it's used by everyone in astronomy. It's an invaluable resource, and it's reached a level of kind of precision and accuracy and fit to what the subject matter experts need that make it really an indispensable resource. I could talk for an hour about how great ADS is. I'm also involved in archive as a moderator in the AstroPH category. And so as part of that, my tech experience is centered on TeX and LaTeX. I don't really know anything about context. And I've also been involved in open source software development for a really long time. So I'm definitely interested in scholarly communication. And one of my really strong beliefs is that there's just this enormous gap right now between how we could be communicating using the tools of the 21st century, interactive digital displays, mobile internet, cheap and ubiquitous computing, networking, cell phones, and how we actually use them in practice. And my view is that that gap is almost entirely about the tools that we have to create documents that take advantage of the new mechanisms that we have. So, as a scholar, we have tools and practices that have been around for hundreds of years that are really, targeting paper in the sense of, they're built as if that's sort of what things will end up on. And for instance, the PDF format is digital, but it's still very much paper oriented in many ways that it works. My view is that, the new technologies that we have open up many possibilities, and that I would say that instead of paper being what you're targeting, you need to target HTML. Computers can run display engines that use things that aren't HTML, but industry is spending literally billions of dollars a year on essentially making the web browser the de facto platform for interactive, networked, high performance applications. And you can think of an electronic document as an application that just has a certain kind of interface. So I think, the fundamental tension that I see is that many of the tools that we have were designed for this, and there's ways that make paper and HTML different. My favorite example is, footnotes make sense if you're, compositing on, hot metal or if you're compositing for a page. Footnotes don't make a lot of sense for electronic HTML documents, I would say. And HTML is used everywhere, so my slides are HTML based. Here is an example of a little interactive figure that I created. This is some stuff about the spectra of radio synchrotron sources, and if I was actually giving a talk about that, I could explain how these different parameters affect the spectrum that you're seeing. But this is an example of something like being able to interact dynamically in the context of a presentation. I think is a very powerful capability that really relies on something like a web browser. I don't think you could build this in PowerPoint. Of course, for a long time, the problem with HTML, or a problem with HTML, was that you couldn't do precision typography with it. And I suspect that many of us have memories of things that look like this image on the right of sort of LaTeX to HTML output. The first thing that I found happened to have a broken image link. But people have done the best they can with the tools that they had literally 20 years ago. But you couldn't do, say, precise math formatting without sort of embedding images. And as long as HTML has that limitation, targeting HTML doesn't make a lot of sense. PDF is the direction you want to go if you want to, distribute technical documents digitally. And by technical documents, I mean things like, academic papers, manuals, things that tend to be long, things that tend to have a lot of equations, things that tend to have a lot of cross-references and external references, things that have figures, tables, and nowadays things that involve embedded code and embedded execution of code. For me, the watershed was in 2011. The toolkit pdf.js came out. This is a PDF renderer implemented in JavaScript that can run the web browser. So if you can render PDFs in the web browser, then you can do that precision typography in the web browser. And this was sort of, the web circa 2000 could not do this, but that billions of dollars of investment that I mentioned before has accumulated to the point where you can absolutely do the precision typography that you need in the HTML target format. My claim is that tech as a system unfortunately cannot produce the HTML that we would need to develop documents that really take advantage of what you can do in a 2020s web browser. I would say that this is not something that you can do with a style file. You need to really add a lot of new code to the engine, and I believe make some changes to the core of the tech implementation. I was interested in trying to attack this and trying to produce this kind of HTML. But in short, what I found was that the TeX code base is really hard to develop. It's written in the web language, which occurs essentially nowhere else. That's translated to Pascal, which is translated to C, which is compiled with other things. There's sort of the rules about distributing modifications. And then just, it's been around for a long time. So a lot of the infrastructure is, very old. And, frankly, as someone who is used to lots of, fun modern development tools, some of those tools are kind of like things that I think are fads and will go away in a few years. Other things, there have been a lot of real improvements that are not part of what I'd call the developer experience for working on tech. So for me, I basically decided that I could not attempt what I want to attempt within that whole framework. I don't want to try and, write new code to HTML in web. And I don't want to deal with, the standard C compiler, auto tools mess. I want to use Git, and I want to center things on GitHub and have things like continuous integration systems. So I want to say that, there are absolutely good reasons for why the sort of standard tech developer, again, my main experience is Tech Live, there are absolutely good reasons for why they are where they are. But I would just frame it as, I think there's a lot of opportunities that are sort of closed off by that historical system. So the Tectonic Project is essentially aiming to seize those opportunities. So I launched it in 2016. And so in terms of the big picture vision of, the world that I would like to see, the vision that we have is, I want it to be easy to create these digital HTML technical documents that, are good and are useful. I think that many of us probably hope that those two things are co-aligned, but, they're not necessarily identical. Where creating these documents is something that's reliable and reproducible, where the tech language, can be used in anywhere that you'd like to use it. And we're using tech is fun. And, even like, brings joy. I think of it as kind of like, as a physicist learning calculus for the first time. And, when you're a kid, you have these ideas. And if you're interested in math, you're sort of like, okay, like I feel like there's something there. And then you learn there's this whole, beautiful system for doing these things. And that just sort of unlocks a huge amount of potential. And I think using tech to create documents can be like that. It would also be nice for Tectonic to have a logo, but we don't have one right now. So I won't talk about this so much here, but a key element of this is, I think, for this kind of trying to do this stuff in a system that's derived from classic tech, but is its own thing, is this idea of, it has a brand and a brand identity, and those are kind of marketing buzzwords, but I think they are actually the right way to think about this, and I think they are important for what Tectonic is trying to do. It's explicitly, in the world of tech, but not extending the classic engine in the way that ZTech or LuaTech or we'll hear about high tech are. So in the details and particulars, so Tectonic is delivered as a single self-contained executable. When you download the release, you get a tarball that unpacks to a single file. And that includes the traditional engines where it's ZTech based. It also includes BibTeX and the XDVI PDFMX, and some support stuff to go along with it. But sometimes it's a little bit ambiguous to people. Like, you don't need a Tech Live install. Everything is in that one file. It's a 50 megabyte file on Linux, but everything is there. So the actual engine implementation is based on the C code generated by the traditional Web2C pipeline, with a lot of extensive work to sort of refactor it. And so this is a link to the repository that kind of automates that process deriving from the Tech Live Subversion repository. So with that manual refactoring, it is a fork essentially. And so I synchronize with Tech Live when it comes out, but that's a manual process where I run this processing, compare the updates in the Tech Live code to what I've got, and manually transfer those changes. That's the price of bundling the code this way. Everything else is written in the Rust language. So this is one thing that over the past years I've become just an absolute fan of. Rust is, you could call a systems language. It's a language that you would use where you use C or C++, and it is just so much better. I believe, Rust will emerge as like a really important human achievement of, achievement of human civilization in the world of software. It is transformative, and I basically never want to use C or C++ again if I can avoid it. I can't, but it's got some really important ideas and some really important design choices that really transform what it's like to write programs at this sort of systems level.
I'm glad you're resisting the hyperbole, Peter.
I can go farther, but in the interest of time. So one particular thing is that Rust packaging compilation model is a great fit for a project like Tectonic. It tends to build towards executables that have very few external dependencies. So it's kind of a static, it's not purely static, but it's a static compilation model where the resulting binaries only depend on a few external libraries. And I think in the modern software ecosystem world, that just is a lot easier than trying to get your shared library dependencies on, Harfbuzz and everything, right? I would say that Rust and Tech are similar in spirit, where they both can be challenging but rewarding. And the spirit that I want to convey with the Tectonic Project aims a lot of what I would say has made Rust successful. There's an orientation towards the whole ecosystem, lots of tooling to support what people do. In the case of Tectonic, this is more of an aspiration than a reality. But I would say that our continuous integration infrastructure automates a bunch of stuff in a way that I think is really important. Tries to be welcoming to beginners, tries to really focus design choices on how people will use the tool, and focuses on, again, this is more aspirational, but giving really great error messages. Here's an example from Rust where, just imagine writing the code to just emit the ASCII that helps convey this error message, multiple overlapping underlines and carets and whatnot.
I think stop. I know that you've had an impossible task to fit everything into 15 minutes.
Am I out of time already?
Yeah, but there's still the second hour, so
okay.
People that have special interest will.
All right, I didn't think I missed that badly.
The presentation with you.
All right.
You've done really well.
All right, I just want to show one thing where, here is some actual math in HTML along with web code. Okay, I was trying to move as quickly as I could, and I didn't even succeed very well at that. I have lots more to say.
Okay, so, well, thank you very much. And over to Dennis.
Okay, gladly. Right. So the idea behind the STEC system is based on the following observations. I perfectly agree with Peter when it comes to the importance of HTML. And in that regard, basically scientific publishing is stuck in the last century. That's something we should want to change. And if you think about the kinds of stuff that HTML has to offer, specifically with respect to STEM, and specifically with respect to actual document fragments in STEM, you will notice that lots of the things that you might want, like showing definitions quickly in the documents, doing in-document computation, searching properly documents by their semantics, you'll notice that all of these things become more useful the more you know about the semantics of the stuff that's in the document, which is a good thing because when it comes to math, we know very well how to represent the semantics of mathematical statements, definitions, theorems, proofs, all of that. That's exactly what theorem prover systems do. The problem with those is that usually they're not intended to yield documents that people can even read. That's one thing. The other thing is that they're fiendishly difficult to use, as anyone can attest to who's ever tried to using one of those theorem prover systems. The solution to the latter point is the notion that you don't have to introduce formality into documents up to the point where you have fully formal machine verifiable statements. It's not an all or nothing thing. You can introduce a little bit of semantics and then you get some features. If I have the time later, I can gladly show you what I mean by that. And the second thing is we also know that LaTeX isn't going anywhere. The entire publishing industry in the 21st century still massively depends on pretty nice looking PDFs that you can print and that should be optimized for print. And the entire publishing industry banks on LaTeX, basically, with respect to that. There are good reasons why one should disrupt that, and one should disrupt that soon. But this is the result of several strongly interconnected systems, all of which depend on each other. And if you want to disrupt those, you have to attack all of them at once. And I don't think it's happening anytime soon. Besides, the thing that LaTeX is good at, LaTeX is just really, really good at. So what we figured what we do is we take these representation principles of formal mathematics, we relax them a bit, we introduce them into standard LaTeX, so you can just still write your papers, but with semantic annotations. And additionally, we build a mechanism that allows us to generate semantically enriched HTML from those documents, and then integrate semantically informed services. So this whole pipeline depends on three things. The first one being the STech package for LaTeX. It's really just a standard LaTeX package. You can import it anywhere. And using that package, you can declare semantic macros, which represent mathematical or STEM concepts. You can organize these semantics in a proper interconnected module system, which allows you to like collaborate and have like the whole community build up new libraries, similarly like LaTeX packages already do. Then we use the Rust-Tex system to convert LaTeX to HTML. Again, I perfectly agree with Peter. You should all write all of your code in Rust, if at all possible. And then as a final piece, we have the MMT system that can import the HTML, extract the semantic information, assemble up to fully formal mathematical expressions out of that could in principle even be fully verified if you're willing to put that much work into your documents, and then host the HTML as an active document with various services that act on the semantics of the stuff that's in the document. Here's a link to where you can like look at all of our documents. By now we have like 3,000 plus pages of mostly just course materials of Michael Kohlhaase's lecture notes, where Michael Kohlhaase is my boss and collaborator. We have relatively decent libraries with already reusable semantic macros up to more than 2,250 by now. And we've now also started writing like actual research papers in STech, which we then submit to Springer or upload on the archive and they compile. And yeah. Just so you get a rough understanding of how this works, you can do symdecl, this command, to declare a new mathematical concept, in this case, the natural numbers. That gives you a macro \nut, which you can then use to annotate arbitrary text fragment as this represents the concept of natural numbers. Or you can provide a notation, so you can use it in math mode and we'll just print the usual Blackboard N. What that means for a user, once someone has gone through the trouble of declaring these things, just using it can be as simple as just writing nut plus ABC instead of A plus B plus C. You can collect these symbols in modules, which you can open up with begin as module, end as module. And if you do that, you can subsequently import them in other modules or use them anywhere in your document you like, which allows you to bundle these symbols in meaningful ways. You can provide several definitions. You can put theorems in there, which you then can also either import and you just get the semantic macros, or you can basically input ref them, which means all of the document text will also be put in your document if you want that. Yeah. I'm not going to talk about Rust-Tech too much or about MMT. Instead, I figure I'd rather show you what this looks like. This is basically a random page from Michael's lecture notes in artificial intelligence. This is all generated from HTML. The PDF looks very similar, as you can imagine, except that this is now a like beamer frame. And then if you hover over any of the symbols and you ask yourself, well, what does that mean? Well, apparently this is the conditional probability distribution. What even is a probability distribution? Okay, random variables. What is a random variable?
I'm not sure if we're seeing what you're trying to show. I only see a links slide.
Oh, I'm very sorry. I thought I'd shared my whole screen. Is this better?
Yes.
You should be able to see my browser now.
Yeah, I can see full joint probability distribution.
Yes. Okay, wonderful. Yeah. So these are the HTML documents that we generate from LaTeX. And then you can hover over these things and we will tell you what this even means, all of these various things. So here's the definition of a joint probability distribution. We don't have text for random variables, apparently, but we do have text for sets and Bayesian networks. Yes, and that's the kind of thing that we're aiming for. We by now, I'm going to switch back, also have like a proper IDE in the form of a VS Code extension that helps you with all of these semantic annotations and integrates all of the software that you need to immediately compile things to HTML and can also directly host these active documents. Yeah, we welcome anyone who's willing to like toy around with this. We appreciate all kinds of feedback. The current implementation is very new, but I think it's now approaching a degree of maturity where you can let other people toy around with it. Yes, and I think that brings me to the end. Thank you.
Well, we could take a few questions for Dennis if we have them. I've got a quick remark, which is I've come across quite a lot to something called NLab, which is a collaborative wiki for maths, physics, and philosophy, mainly physics, high energy sort of physics, and mathematics associated with that. And it seems to be that it's trying to give definitions of everything as best it can and provide it in a hyperlink basis. And I wonder if you've come across it and you had any comments about it.
I'm not entirely sure if I'm now confusing NLab with NCATLab, but I think like in spirit, they're the same thing.
Yeah, I think that's what's happened.
Yeah. I know NCATLab as mostly this repository where people are scared to look at any definitions because they're written in this very category theoretic jargon, which is very hard to understand for anyone who's not into category theory. But it's a beautiful homepage, and that's kind of the thing that we're trying to go for, except in a more reusable and open fashion, right? So the NCATLab exists, but you can't like, you yourself when writing documents can't refer to the content in the NCATLab.
Okay,
so that's the kind of thing that we're trying to add to the same idea. Otherwise, in spirit, yes.
So it's part of the mix of ideas that is influencing all of us.
Yes, very much so. The same goes for example, for the Stacks project, if you've heard about that. It's also a giant web-based project where I think they're using TeX in the back end, but they're also generating HTML from it, where they try to build a textbook about stacks and sheaves and all of these things. I know very little about that area of, I think it's algebraic geometry, but...
Let me go into that. I've got a background in algebraic geometry and stay a PhD in the subject. And I went to a conference on databases in mathematics, and the NCATLab was one of the databases brought up. And there are other mathematical databases, such as the Online Encyclopedia of Integer Sequences,
Yes.
and also massive databases related to elliptic curves and so forth, which are sort of, some of them record computations, some of them record information, some of them record both.
The LMFDB, I think you mean, right?
Sorry? Shamsi, do you want to say something?
I could sneak in a question. Dennis, you had mentioned that you preserve the document layout from TeX.
Yes.
And I wondered if that was the layout of math, or does that extend to things like if there's a 2-column layout, then you preserve that?
2-column layout I can't preserve, but it does preserve the column width, which is awful. So if you convert to HTML, you first want to turn off 2-column. But yes, the conversion engine Rustec actually works by re-implementing the core of plain TeX. So all of the HTML conversion happens on the level of TeX whatsits and then associating CSS classes. So it's as close to what TeX does at its most internal layer as at all possible.
So how does your
I was actually just about to ask about that. So yeah, I can skip.
We have another hand up, and I think we're also at time.
Yes, sorry, I didn't put my hand up. One last question. How can you describe succinctly how your project differs from Peter's project? I get part of it in the sense that you're extending the vocabulary of TeX, so to speak. But when you convert, you said you're implementing this inside the TeX engine, and it seems Peter's re-implementing the TeX engine.
I mean, I can say that we're definitely not doing HTML at the whatsit level, so that's a different approach.
And when it comes purely to the generation from HTML, it's basically the other way around. I re-implemented TeX from scratch in Rust. I didn't even look at the original TeX code.
And you have a complete re-implementation?
As complete as I currently am aware of what's needed. I know there are some things that I just won't be able to do. That, for example, includes PDF literal. I don't know what to do with PDF literals in HTML. There are some macros which TeX has, which I haven't yet implemented, like the one that reverses the direction of the text. So it switches from right to left. I also don't know how to do that. But everything I've so far found that I need, I have.
Okay, we should talk.
I see Martin has his hand up. Jonathan, do you want to leave that question for after the third presentation?
Well, I think we have to stop Martin asking a question so that we can make space for the next speaker, who happens to be Martin.
Yeah.
And then there'll be a little bit of time at the end.
Okay, I think I will postpone my question and start sharing my screen. Okay, this should be it. Okay, I hope you can see it now, the screen. And I want to start with 2 pictures. This is a photograph of one page in the Art of Computer Programming. And I want you to focus on the line here in the middle. I hope you can see the mouse where it says since P and K equals and so on. And when this page was translated for an ebook reader, it looked like this. And after a while of searching, you find here since P and K equals P. And then the line continues with N with a subscript. And this is one reason why Don Knuth did not want his books to be available on ebook readers. And this is where I started my hint project, where I wanted to have a TeX engine and an output that can be used on an ebook reader that would give output that is comparable to the output that you expect from a book. So the difference between targeting HTML, as we have seen it now, for valid reasons, and what I tried to achieve was targeting an electronic book. And for an electronic book, the main difference I see is that with a web browser, you basically, as an author, make content, and the actually presentation of that content is left to a large degree to the browser. That at least was the original idea of HTML, but nowadays authors want to really control how the presentation is, how their content looks like, and many features have been added to HTML to make that possible. But my approach was from a different angle, and the result, we can move that out, is now the hint file system, which is an output format like PDF for TeX, and a viewer. And the new viewer that I just wrote was the viewer for the Mac OS, and it shows you some of the features. So I start the presentation now. Today, I present the hint viewer for the Mac OS operating system. To open a hint file, I double-click it in the Finder. Here we see the LaTeX sample file. You can change the zoom factor by dragging with the mouse, making it larger or smaller. You can page forward and backward. You can also change the window size, and the text will reflow to the available space. When you page forward and then reflow the text, the beginning of the page will stay fixed. The same is true if you change the zoom factor. Most operations in the hint viewer can be achieved with mouse movements or keystrokes, which are documented in the help file. For instance, you can use the N key to switch the view into night mode, which some people prefer when reading in a dark environment. Or you can reset the zoom factor to 100% to make the document on screen appear at exactly the same size as it would be in a printed book. Next, let's look at searching. You can open a search field and type in a search text. While you are typing, occurrences on the current page get highlighted in red, like here and here. You can move from one occurrence of the text to the next and have the text highlighted in green. And the viewer will change pages if necessary. You can navigate to the so-called home page, which in this case is the first page of the document. This is not necessarily so. Let's look at another example. It's the definition of the hint file format written as a literate program using the CWeb system. The CWeb macros support the generation of hint links. Making the viewer start a file on its home page can be selected on the Preference pane, as well as other things like the gamma correction to make the fonts heavier or lighter to adjust for the properties of your monitor. Now let's look at the links. Clicking this blue link navigates to the Scanning the Long Format section. Clicking here shows the entry in the bibliography. The T key gets you back to the home page. The table of content can be made available as an outline. Selecting an entry in the outline repositions the document as requested. Let's go to the index. And here we select, for instance, the \@ entry, and it moves to the position where its use is explained. You can click the section number for the scanning definition, and it brings you to the start of them, which are used in section 519. And by clicking, it renders section 519. Let's look at another topic, images. This example contains a PNG image, a big letter A, which scales together with the surrounding text. This is not necessarily so. The next example shows the head of a lion, which again scales with the text. And there is also a full lion, which scales with the horizontal size of the window, respecting the vertical size of the window if necessary. The size of the head is defined in point, the size of the large image as a function of the horizontal page size. Now let's look at displayed equations. Here we have some formulas centered on the page. They remain centered when the window gets smaller. But there is a point where TeX decides to center them in the space between the margin and the equation number. As a measure of last resort, TeX moves equation numbers to a separate line. Of course, you can undo all this by making the fonts smaller. The last example uses the preface of the Metafont book to illustrate printing. I start with the page setup. Changing the paper size from A4 to US letter, for example. When I now use the print dialog, the preview will show me how the text will look when formatted for letter size paper. It uses just 3 pages. I can select a printer or select PDF output. I give the file a proper name and save it. It will render the document, which you can see here in the Finder. By double-clicking it, you get a PDF viewer showing you the PDF output for letter size paper. This concludes my presentation today.
Okay.
Well, so far this presentation of what I have achieved in this project. And I must say this is a research project, and my interest was in finding out what information do I need at the very end when I render a TeX document, and how I can extract that information from TeX when it is running. Because in a normal PDF or DVI output file, a lot of information that is in the TeX file itself is lost. For instance, words get hyphenated, and then you have the hyphen in the text, and the hyphenation might split a ligature into different characters, and so the ligature gets lost. There are other things like the different settings that the author used to break lines into paragraphs, into lines, and all that information is retained when I generate a hint file, so that in the viewer I can run the original page breaking and paragraph breaking functions of TeX and render the text on demand. This is probably where it meets with the things that we have seen earlier with HTML. Just it's a different output media, but I see a great overlap between what I did and the demands that a good HTML representation of the hint file format includes something like a paragraph node, and it retains the text. It keeps all the different hyphenation points that TeX eventually might use or might need to use, because in the viewer I don't do hyphenation, because I do not even do any language processing. All that is done by TeX earlier on. And all the different parameters for typesetting the paragraph are retained, and they can be used in the output format to generate exactly the same paragraph that TeX would generate with the same horizontal or vertical size. So I have a clear idea of what is needed on information to get high quality output from TeX, and how to get that information from TeX. And I think maybe even converting a hint file to HTML would be a viable way of generating HTML output, because all the front end, the complicated thing of TeX is not the output format, but it's the front end where all the macros get expanded, and all that is a really complicated thing. The back end is actually quite simple. It contains just characters and boxes and glue, and translating these to HTML is probably much easier than taking the TeX input and all the processing, and then doing all the processing that TeX does on the input before it gets to lists of characters and boxes and glues and that kind of stuff. Well, there might be a joint ground for HTML or hint output.
Thank you so much for that. That was really fantastic. I think Jonathan was hoping we'd lead into breakout groups and continue the discussions. Is that right, Jonathan?
Yeah, I sort of make it a rule that we're good at closing, allowing people to leave when they want to leave at 1/2 the hour, which is just sort of 6 or 7 minutes time. Can we thank all the speakers by unmuting our microphones and clapping as loud as we possibly can? If anybody's wanting to go but wants to say something to all of us, they should have an opportunity to speak now.
Well, Jonathan, are you breaking out the 3 different sessions?
That's decided by all of us, and Shamsi will take a lead on that.
Because I have about a dozen questions for each of the presentations. Except maybe Peter's, because I've spoken to him before, but he should get to finish his slides.
I'm a strong believer in sticking to your time allotment, so that's probably the worst I've ever whiffed, but I don't want to overrun.
I think we sort of need to get some sort of consensus as to what we're doing, and there will be a plenary at the end where things get reported back. If you put something into the chat of the main session, it'll go into the recording, so it won't be lost, although it may not be dealt with today. So if you've got a dozen questions, put them into the chat or send them by me to email.
There's just a lot of follow-up needed, especially for Dennis and Martin's work to get more clarity.
I wonder if, unless there's a strong feeling that breakout groups would be helpful, if we should just remain together.
Yeah.
And would it be helpful to have a short break first and then we come back refreshed?
Yeah, I'm free all afternoon, by the way, so.
Okay, so we're going to have a short break. And during that short break, people can put into the chat any suggestions they have for topics or questions that they want to discuss. Does that seem to take us forward?
Sure.